In this video, we will learn how to write chemical formula and chemical names of ionic compounds. So first, what are ionic compounds? By definitions, ionic compounds are those that consist of cation and anion in them. Cations are anything that is positively charged, versus anion are anything that is negative. So let's write it down. Cation is anything that is positive, versus anion are basically negatively charged. A cation can have a charge of +1, +2, +3, and so on. And an anion can be -1, -2, -3, and so on. Cations and anion are further divided into two types. For cation, we can have a monoatomic cation. And similarly for an anion may be monoatomic as well. A monoatomic anion are normally formed from nonmetal. When a nonmetal gains an electrons, it's become a monoatomic anion. And as for the monoatomic cations, these are formed from metal atoms. When metals give up the electron, they become ions, and cation to be more specific. And in this case, we will call them a monoatomic cation. So that is the first types of cation and anion that we would see. Cation and anion can also be polyatomic as well. So we can have polyatomic cation. And we can also have polyatomic anion as well. What are polyatomic cation and anion? These are basically ions that can consist of multiple atoms in them, and overall they have a charge on them. For an example, a polyatomic cation would be N is 4+. So here in this case, we are calling this a polyatomic cation, so it consists of up to 5 atoms in it, 1 nitrogen and 4 hydrogen, and overall there is a positive charge. So this will be classified as a polyatomic cation. An example of a polyatomic anions is as follows: nitrate, NO3 with a charge of -1, or sulfate, SO4 with a charge of -2, and so on. So these are examples of polyatomic anion, and again they consist of multiple atoms in them, and overall they have a negative charge on them. So in theory, any cations can form ionic compound with any anion. They just have to be present in such ratio so that overall the compound is neutral. We can have ionic compound where we have a monoatomic cation form an ionic compound with a polyatomic anion, or we can have a monoatomic cation form an ionic compound with a monoatomic anion. And similarly, we can have a polyatomic cation form an ionic compound with a monoatomic anion, or an ionic compound between polyatomic cation and a polyatomic anion. So any of this can come together. We just have to make sure that they come together at certain ratio so that overall the overall choice is neutral. And that's how we would be writing chemical formula of ionic compound. And for this reason, this is why it is very important that we define the definition of ionic compound very carefully. And we should always define it as compound that consists of cation and anion. The definitions that ionic compound are those consist of metal and non-metal is not inclusive enough, because that only covers this part right here that we have seen. Now, before we get going on, to further learn how to names and write chemical formula of ion or compound, we need to first learn how to recognize the monoatomic ions. So let's now go over name and formula of the ion or compound. Once we have learned how to names and write formula of the monoatomic ions, to name the ion or compound, it's really easy. We just name the cations, follow the anion, and we take out the word ion in them and combine together. That's how we would write names of ionic compound. So first, let's now learn how to write names of monoatomic ions. And again, monoatomic ions are basically ions that consist of a single atom. Consists of a single atom. And overall, it has a charge on it. It's really easy to figure out what is the charge of an ion by looking at the periodic table. So we have seen already that the periodic table is further divided into metal and non-metal. So here are the elements in green. This separates the metal and the non-metal. Everything on the left side of these green blocks here are then called the metal. And everything to the right side of them are the non-metal. When forming monoatomic ion, metals form cations and non-metal form anion. So thus it's important that we know what types of element they are. Are they metal or non-metal? And one of the other things that we can also recognize from the periodic table is the types of charges that each of these elements would form when they form ion. Group 1 metal, when forming monoatomic ion, they will be positive 1. And group 2 element will then be positive 2. Skipping the transition metal, and we will go back to visit the transition metal in a little bit. Moving on to group 13 metal, aluminum for an example, 80 plus 3. And now moving on to group 17, the halogen. Halogen are all negative 1 when they form monoatomic anion. Oxygen or group 16 element form negative 2 monoatomic anion, and group 15 form negative 3. Now we do not see a chart for group 14 because group 14 rarely ever form ionic compound. They do not become charged. Let's now learn how to write names and chemical formula of mean group metal. So in writing the formula, then the formula consists of the symbol of the element followed by the electrical charge that is written as a superscript. And when we name them, we name the element followed by the word ion in them. Now we are not specifying the charges because the charge is something that we can figure out by knowing where the elements are on the periodic table. For an example, if we were to have a group 1 element, for example sodium, when forming ion, sodiums form the plus 1. So in this case, the formula of ion will then become plus 1. And the reason is because group 1 elements have 1 valent electron. They like to give up 1 valent electron to become octet, therefore become positive 1. And when naming this sodium ion, we'll call this simply sodium ion. Again, we are just saying that this is an ion, but we're not specifying its charge. Its charge is something that we should be able to figure out. Here in this case, it is plus 1. So imagine if we were to cover this, the left side, the chemical formula. If we were to cover this up, and we simply is just given sodium ion, it is expected that we will be able to write a formula as sodium with a plus 1 in here. Another example, group 2 elements, sodium or magnesium. So magnesiums, when forming ions, it like to give up 2 valent electrons, therefore become positive 2. And when we name this, it be called magnesium ion. And again, we are not specifying the charge of magnesium, but knowing that this is an ion, we will be able to figure out that it is positive 2. And similarly, group 13, aluminum. Aluminum, when forming ion, it like to form cations, and because it have 3 valence electrons, so when given up 3 valence electron, it become plus 3. And when we name this as aluminum ion. So that's how we will write formula and names of main groups metal. Moving on to name and formula of the nonmetal. And again, when forming an ion, the nonmetal form the anion. And to write a formula, the formula consists of the symbol of the element followed by its electrical charge written as a superscript. And when we name them, we will then name the element, and now the ending of the element is then changed to IDE. So IDE is indicative that it is negatively charged. For an example, group 17, Cl. Group 17 have 7 valence electrons. So in chemical reaction, they would like to gain 1 more electron, and therefore become Cl -1. So that's how we will write its chemical formula. And as for its name, this become chloride. So we can call this chloride ion, and whenever we see chloride ion, by knowing that it is ending in IDE, we know that it is negatively charged. And because this is an element from group 17, we will be able to figure out that it is actually -1 in its charge. And similarly, group 16, they have 6 valence electrons. So in chemical reaction, they like to gain 2 valence electrons and therefore become -2. And to name them, for an example, sulfur with the charge of -2, this become sulfide. Sulfur becomes sulfide. So we can call this sulfide ion. And again, even though when we say this is an ion and we're not specifying its charge is something that we are expected to be able to figure out. Here in this case, sulfur come from group 16, and group 16 form -2 anion. So therefore we know this is sulfur with a charge of -2. And another example, group 15 element, they have 5 valence electrons in them. So in a chemical reaction, they like to gain 3 valence electrons and therefore become -3. And to name it, we would call in this case phosphor with charge -3 become phosphide. So whenever we see the IDE endings in the name of an ionic compound, we know that it is the anion, and its charge is something that we can figure out by looking at the periodic table. Let's now go over names and formula of transition metal. Transition metal, when forming ions, they become cation as well because they are metal. What makes transition metal unique is that when they form cations, they can have various charge in them. And the charges of the transition metal is something that we call the oxidation state. For an example, iron have 2 oxidation state, +2 and +3. So here in this case, this is saying that when iron form ions, it can become +2 or +3. And this is quite unique compared to the main group metal, because main group metal form only one type of charge. They can either be +1 or +2 or +3, but never both. And here in this case right here, we are seeing the exception with the transition metals. And again, transition metal can form various charges in them, and they have different charge to them, and we call each of that charge an oxidation state. And because metal, when they form ion, they can have various charges to them, it becomes very important that we specify what is the charge of a transition metal in a particular compound. And to indicate the charge of the transition metal, we would be using the Roman numeral to indicate the oxidation state of the transition metal. And the use of the Roman numeral is not needed if the transition metal have only one oxidation state. So not all transition metal have various oxidation state to them, but only some that will have various oxidation state. For an example, if we go back to this periodic table, we will then see. So this is a very abbreviated version of the periodic table, but we then see zinc have only one oxidation state. It has only one state of its charge, in this case +2, and silver is +1. So again, we would then be saying that silver has only one oxidation state. Now, iron, we can see here +2 and +3. These are the two oxidation states of iron. And chromium are +2 and +3. Now, chromium can also be +4, +6 as well, and they're not listed here on this periodic table. So this periodic table only listed some of the common ones, and many of them are still missing. And we also see here copper have two oxidation states, +2 and +3. Because the transition metal have various oxidation state to them, in one ionic compound, a transition metal may be +2, whereas in a different ionic compound, a transition metal, a same transition metal, now have the charge +3. So it's very important that now we specify what is the charge of the transition metal in a particular compound. And again, that is the reason why that we have to use the Roman numeral to indicate the charge. So that way it's not ambiguous, because we don't know what charge that it is forming. And again, if the transition metal has only one oxidation state, for example zinc or silver, then that is something that we don't have to specify, because we know that zinc is +2 and silver is +1. Going back to the example with iron, iron has two oxidation states. So iron, in chemical reaction, it can give up 2 electrons to become iron 2+ by losing 2 valence electrons. Iron, in chemical reaction, it can also lose 3 valence electrons, and that when it becomes iron 3+. How would we name and distinguish between this iron 2+ and this iron 3+? Then the answer, we name them as follows. We would name this as iron, follow the Roman numeral 2, ion. And the iron 3+, is then named as iron with the Roman numeral 3, followed by the word ion. So that's how we would names to distinguish between the various oxidation states of a transition metal. Now, iron 2+, for a long time, or in the common name method, we also refer to as ferrous. Whereas iron 3+ has a common name that we call ferric. So one have the ic ending and the other one have the us ending. And these are common names that have been used for hundreds of years. Not all transition metals have common name to them. So here in this table right here, this lists some of the common names of some of the transition metals that would be good for us to remember. Now, the systematic name is one that we would always use, and we encourage students to now use this systematic name. But because the common and the trivial name are still being used in certain textbooks, therefore, we want students to be able to recognize when they see one. So for an example, chromium have 2 oxidation states here in this example, +2 and +3. The chromium +2, when named systematically, is called chromium 2 with the Roman numeral 2, and the chromium with the +3 charge, when named systematically by then it will be chromium with the Roman numeral 3. The chromium 2 is then also named the old way or the common way as chromous, versus chromium 3 is then named with chromic. And similarly, we can see some of the other common name for some of these other transition metals. So whenever we see an example of a transition metal, for an example, copper 1, we can name it copper 1 or we can name that as cuprous. And notice the following. Of the two oxidation states in here, the one that is high in charge would be the one with the ic ending, and the one with the lower charge have the us ending to it. And that is something that we can find consistently in all of the common names. So cobaltous is plus 2, cobaltic is plus 3, cuprous is plus 1, cupric is plus 2. So the ic and the us do not specify any particular charge, but then it simply does say that this is the one that is high in charge or the one that is low in charge. The ic is the one that have the higher in charge, and the us is the one with the lower charge. Let's now put all of this together to name and write in formula of ionic compound. So in theory, a cation of any charge can form ionic compound with an anion of any charge. They just have to be present in the correct ratio so that overall the chemical formula is neutral. So name and guideline of ionic compound. When we name ionic compound, we name the cation first, followed by the anion. It is thus important that we know how to name cations and anion individually before we put them together to name the ionic compound. If we were to have a transition metal having various oxidation state or charge, then we need to specify what is the charge of the cations by using the Roman numeral inside the parentheses. And the subscript prefixes such as mono, di, and tri are never used in the naming of ionic compound. We do not have to include how many of the cations and how many of the anions that are present in an ionic compound. And the reason is it is something that we can figure out, because again, the chemical formula of an ionic compound has to be neutral. So once we know the charge of the cations and the anion, we should be able to figure out how many of each that we should have in order to have a neutral ionic compound. For an example, NaCl, if we were to name this, how would we get started? So the first step is to identify whether this is an ionic compound or not. And here in this case, we see that sodium chloride is an ionic compound. Why? Because we know that we have a metal, sodium is a metal, and chlorine is a nonmetal. Whenever we have chemical substances consistent of metal and nonmetal, then that would then imply it would be an ionic compound. So separate the metal and the nonmetal. And now, we know this is an ionic compound, so they have to be charged on them. In this case, the sodium forms the cation, and the anion is the chlorine. And the charge of the sodium is +1, and the charge of the chlorine is -1. So that's the charges for them. So therefore, when we name this, it will be sodium. That's the name of the sodium cation, sodium. And now we take out the word ion, followed by the Cl. The Cl is the chlorine, but again, this is an anion, so therefore it is chloride. Putting both of this together, the name of this ionic compound is sodium chloride. Next example, NgI2. How would we name this compound? So again, we have to first recognize what types of compound it is. And in this case, this is an ionic compound. And the reason why we know this is an ionic compound is because it consists of metal and non-metal. Magnesium is a metal, and iodine is a non-metal. compounds consistent of metal and nonmetal are ionic compounds. And once we recognize that these are ionic compounds, we now need to figure out what is the cation and what is the anion and what is the charge on both of them. So here in this case, magnesium is the cation because metal from cation, and the iodine is then the anion and its charge is -1. So when we name this, we name the cation first, which is magnesium, followed by the iodine. Now, in this example, we are not specifying the charge of the magnesium or the iodine because that is something that we're supposed to be able to figure out. When we see magnesium iodine, immediately we should be thinking that this is an ionic compound. And therefore, here in this case, this is -1 and this is +2. Because the charge of the iodine is -1, therefore there has to be 2 iodine for every 1 magnesium, so that overall the charge is neutral. Let's now try another example. How would we name this ionic compound? So in this case, the aluminums is the cations and the oxides is the anion. And again, aluminum is a metal and oxygen is a non-metal. So therefore, they will be forming an ionic compound. Although we don't need to figure out the charge of it right now, but if we were to ask for the charge of the aluminum and the oxygen, then we should be able to see that the charge of the aluminum is +3 because it group 13. And oxygen, each of the oxygen is then -2. And now when we name them, it will be aluminum followed by oxide. Aluminum oxide. And that will be the name of this ionic compound. Next example, CuO. How would we name this ionic compound? And here in this case, this is our cations because it is a metal, copper. Where is copper? Notice that copper is a transition metal. So therefore, in this case, we have to specify what is its charge because copper is one of the transition metal. They have various oxidation state to it. So we have to figure out what is the charge of this copper. Now the charge of the copper can be figured out quite easily. Here in this case, we see that overall the compound is neutral. And we know that the oxygen is -2. There's 1 copper and 1 oxygen that make up this ionic compound. If oxygen is -2, and now there's only 1 copper, that makes the charge on the copper +2 as well, in order for their charge to neutralize out. So here in this case, the charge of the copper is actually +2, not the +1. So therefore, we have to indicate that copper 2, followed by oxide. On this next example, Cu2O, how will we name this ionic compound? So here in this case, we have to pick up the charge first because this consists of a transition metal. And this transition metal copper have various oxidation state to it. So therefore, we have to specify what is the charge of this copper. Here in this case right here, it will be easy for us to see that the charge of the copper is actually +1. And the reason is there are 2 of the copper. If there are 2 of the copper, each is +1, that would add up to the charge from the cation being overall +2, and that would then be neutralized with the -2 charge from the oxygen. So in this case, we know that the charge of each of the copper is +1. So that's why this name is copper 1 oxide. And another example, FeCl3. How would we name this ionic compound? So here in this case, the iron is the cation, followed by the chlorine. And again, we have to figure out what is the charge of the ion because it is a transition metal with various oxidation states. And here in this case, we will then see that the charge of the ion is positive 3. Why is it positive 3? Because we have 3 chlorine and each is negative 1. And there's only one ion. So therefore, the ion has to be positive 3. So that way, it can neutralize out the charge of the 3 chloride. So putting all this together, this will be named as ion 3 chloride. And we have seen previously that iron plus 3 can also be named as ferric. So therefore, rather than naming this as iron 3, we can name this the common way as ferric chloride. And next example, to name this ionic compound, it would be iron 2 chloride. It is iron 2 because the charge of this ion is positive 2. And we know this is positive 2 because there are 2 chloride and the charge of each chloride is negative 1. Therefore, the ion has to be plus 2 in order for its charge to be neutral. And iron plus 2 can also be named the common way as ferrous. So in this case, this can be ferrous chloride. So this semester, we will not be requiring students to name ionic compound the common way. For example, the ik and the us for the transition metal is something that we will no longer teach. Formula of ionic compound. We should be able to go from name to formula and formula into name for all ionic compound. So if we are given the name of an ionic compound, we are expected to be able to write its chemical formula. And these are the guidelines how we will be writing formula. So we would always write or list the cation first, followed by the anion. And we need to adjust the subscript so that overall the compound is neutral. We know the cations can be any charge and anion can be any charge as well. But overall, the chemical formula of an ionic compound has to be neutral. So therefore, we have to adjust the amount of cations and the amount of anion so that overall they are neutral. And if the ion is a polyatomic ion, and we have multiple of them, then we have to use the parentheses. For an example, cations are always listed first, followed by anion. And the subscript X and Y here tell us how many of the cations and how many anion that is present. A lot of time, X is the subscript of the cation. And this then equal to the charge of the anion. And Y is the subscript of the anion. And a lot of time, that equal to the charge of the cation. So this is a basic algebra to make sure that overall the charge is neutral. And again, we would only need to use this parenthesis if the cations and the anion are polyatomic ion. If they are simply a monatomic ion, then we do not need to use the parenthesis. And again, one thing is very important when writing formula is that the sum of the cations add together has to equal to the sums of the charges of the anion, so that overall is neutral. Let's now try a few practice problems. Writing the chemical formula of sodium chloride. So here in this case, sodium chloride is an ionic compound, and we know this because it consists of sodium, which is a metal, and chloride, a non-metal. So the first thing that we want to figure out is what will be the charge of sodium and what is the charge of the chloride. So that way we can balance out the charges and write the chemical formula. So here in this case, sodium is +1 and chloride is -1. Sodium +1, chloride -1. So because one is +1 and other one is -1, in 1-to-1 ratio, that's how they are neutral. So therefore the chemical formula becomes Na1Cl1, or simply NaCl. Let's now try another example. What is the chemical formula of aluminum oxide? So here in this case, we know again aluminum oxide is an ionic compound. Because it consists of aluminum, which is a metal, and oxide, a non-metal. Compound consistent of metal and non-metal are ionic compound. So therefore we know this will have charge on that. What will be the charge of the aluminum, and what will be the charge of the oxide? Aluminum is +3. It is because it's from group 13, and oxygen is then -2. So here in this case we have aluminum that is +3 and oxygen that is -2. In 1-to-1 ratio, it would not be neutral. So therefore we have to figure out in what ratio that they need to be present in order to be neutral. And this is the trick that we have seen previously above to help us figure out what would be the subscript of the aluminum and the oxygen. So here in this case, the subscript of this cation become the subscript of this anion, and the charge of this anion become the subscript of the cation. So therefore this become Al2O3. If we would have 2 aluminum, each is +3, overall that would be +6. And if we were to have 3 oxygen, each is -2, so that would add together to -6 as well. So overall, this is neutral. And again, the chemical formula of an ionic compound always have to be neutral. Let's now try another example. Ferric sulfide. Ferric, that is the combination of iron 3+. So here in this case, we know this is +3. And sulfide, that comes from the sulfur anion, that is -2. Because sulfur is -2 and iron is +3, in 1-to-1 ratio, they would not be neutral. So therefore, when we write the chemical formula, there has to be 2 iron for every 3 sulfur. And again, the charge of the anion becomes the subscript of the cation, and the charge of the cation becomes the subscript of the anion. So this is called the crisscross method. Fe2O3. And lastly, another example, silver nitride. What will be the chemical form of silver nitride? So silver is the cation. What is the charge of silver? And if we were to recall from the previous table, silver is +1. Silver is a transition metal that has only one oxidation state, and it always is +1. And nitride is nitrogen with a charge of -3. In order for this to be neutral out, then there has to be 3 silver for every 1 nitrogen. So therefore, we will then see Ag3N. And that will be the chemical formula of silver nitride.